well, let's kick this off. We're going to talk about Blazor, as Scott alluded to earlier. This is a version of .NET, and the focus that I'm going to give today is .NET in your browser, and I'm going to explain what that means in a moment. Just very briefly about myself. My name is Jeremy Likness. I'm here in Seattle, so I'm running a little bit early morning time zone, just like Scott was. I'm a cloud advocate at Microsoft, and we have a unique role. We really focus on community, on curating and creating content, and connecting with engineers at Microsoft. I've been developing for quite some time. I love to run. I shoot for a plant-based diet. Sometimes contamination can happen. And I shoot pool whenever possible. I'm a big fan of billiards. The main reason behind this slide is to give you some contact information. Feel free to reach out to me directly with questions that you might have. Happy to answer those. I want to talk a little bit about some history behind .NET. I think we had a phenomenal intro to .NET Core and this idea that .NET really, as an open source cross-platform tool, can run really anywhere. And here we can see across the top, we've got screens for laptops, for phones, for the cloud, for gaming devices, and for sensors. But there's been a sort of, let's call it a weak spot, if you will, with .NET, and that's the browser. And the web browser is everywhere. Web browser is on tablets, it's on laptops, it's on phones. But traditionally, as developers, when we've gone to build experiences for the browser, we've been told that JavaScript is the language that we have to use. And this is not a session about bashing JavaScript. I happen to love JavaScript as a language, but really we're challenging this question: is JavaScript the only solution for building applications in the browser? And the answer is, with a technology called WebAssembly, there are new experiences available across a variety of languages, including our beloved C#, but there's other languages like Go, Rust, Java that are implemented with this WebAssembly. WebAssembly has even been used as a platform to target the .NET framework. But before I get into that too much, I want to take a step back and talk about WebAssembly itself. What is this mysterious technology that we talk about when we refer to WebAssembly? The idea behind WebAssembly is a sandbox stack-based virtual machine. What on earth does that mean? When you're writing JavaScript in your client browser, you are really writing for a JavaScript virtual machine. And the world that you're playing in is what we call the document object model. It's the way you access the web page, the HTML elements, the styles, the scripts, and JavaScript is able to interact with those. It's a structured language. It's a language designed to run pretty much everywhere. It can run on the browser for Node.js, but in the context of your browser, you're in a sandbox that you have a limited amount of features that you can interact with. WebAssembly provides a similar sandbox, but it does it a little bit differently than JavaScript. JavaScript is an interpreted language. It's a dynamic scripted language. And when your browser loads some JavaScript code, the first thing it has to do is parse that code. It can't trust that the code is perfect code. You can have typos, you can have incorrect code. So it has to parse that code. It has to turn it into something that that JavaScript virtual machine can understand, and then it has to execute it. With WebAssembly, the idea is that you can load bytes that represent code directly into the browser. So there's no pre-compilation script parsing done by the browser. It's loading it directly. And we're going to see what that looks like with a example. This results in a much smaller file size, and I'll show you an example of that as well. But it also allows for a very specific instruction set. JavaScript is constrained by the history of the language. With WebAssembly, it's able to provide different operations within that sandbox that open up a variety of possibilities. So it's easier shown than explained. So what I'm going to do is jump into my first demo here, and we're going to open something called WebAssembly Studio. WebAssembly Studio is a great way to get familiar with WebAssembly. It's a way of building WebAssembly within the browser. And I'm going to pick, I've got a few options here. I'm going to pick this empty what project, which really just stands for WebAssembly text format. So we're going to pick this format and we're going to create a new project. And this is just emulating what I might be doing locally on my laptop over the course of development, what might happen on a build server. But let's look at the components that we have here. I've got this main.html, which is just a straightforward HTML page. We've got a simple style, we've got a span, and we've got this main.js that it's loading. So far it should look pretty normal and natural to anyone familiar with web development. Let's take a look at this main.js file. This starts to get a little bit interesting. It's using this fetch command. Fetch is a JavaScript command that loads data from a URL. It's the way that you might connect to a web API from the browser. It's the new API for connecting to endpoints. So what it's connecting is this weird file name called .wasm. This is an extension for WebAssembly. This means it's pulling in WebAssembly bytecode. When it gets that response, so it's loaded the bytecode, it uses this new WebAssembly object to instantiate the bytecode. So again,
Jimmy,
yes.
So can you zoom out your screen? Can you increase the font size of the screen?
I'm not zooming across the, I'm sorry, I've been using a zoom, but the zoom's not coming across on the recording. So let's do it this way. Is that better for you?
Yeah, now it's better.
Awesome, great. Yeah, sorry, I should have checked to make sure the zoom was coming across. It was looking great on my end. So basically, we've got this new WebAssembly object. So here we're loading the bytecode, and here we're telling the browser to go ahead and run that bytecode. This is getting that instance of the running bytecode, and then notice it's using this instant exports.add. I'm going to explain this in a second, but WebAssembly itself runs inside of a sandbox. It's a security feature, if you will, of WebAssembly in that it cannot directly access or manipulate the document object model. It has to have a way to pass through. So when we take a look at that, we need to specify what can be called in WebAssembly from JavaScript, and we need to tell WebAssembly what it can call into JavaScript. And let's drill into that just a little bit more deeply and look at this. So this is a WAT extension. What that means is WebAssembly text. This is showing us the actual WebAssembly code. Here it's defining a module, saying that we're going to have a function called add. It's taking in one parameter that's a 32-bit integer. It's taking in another parameter that is a 32-bit integer, and it has a 32-bit integer result. Get local places that parameter on the stack. Get local again places it. So think of a piece of memory that's placed the values of these two parameters, and then add just adds the most recent values on the stack. So you can imagine if we have a 1, it puts a 1 on the stack, a 2 on the stack, and then add pops that 2 and 1, adds them together and gives us a 3. The important part here is we're exporting this as add. That means the outside world can reference this WebAssembly function right here in the exports as add. And we'll just change this a little bit. I'd prefer to make this add 41 and 1. So let's go ahead and build this. And what we're going to see is as part of the build project, we get this WASM. That's the bytecode. If I click on this, it's showing me the text-based representation, which looks very similar to the source code. But this is the actual binary bytes. And then if we run this, we can see we get this. I actually need to save my change here. Let's run, build and run, and we get 42 as our answer. So that's very simple. Now, it may be a little bit concerning, if you will, to think about having to build low-level WebAssembly code. But the nice thing is, because of the way WebAssembly is built, it can be a compilation target. In other words, other languages can generate the same way Scott showed you that when you take C#, what's actually generated when you build is this intermediate language code that the .NET runtime understands. In a similar way, WebAssembly bytecode can be generated from a compilation process. So if we come back to the studio, I'm going to refresh this, and this time I'm going to create an empty AssemblyScript project. The AssemblyScript project is a little bit more involved. What this is doing is, if we take this main, we've got a very similar HTML page that references this JavaScript. If we look at the JavaScript, it's using that WebAssembly instantiate again, but this time it's doing it a little bit differently. It's grabbing this main, and then it's passing in the ability for the WebAssembly to call JavaScript. So this say hello function that just writes to the console, this is the way it's specifying that, yes, we can call that from WebAssembly.
Jeremy, there is one question. What is promise in JS?
Promise is an asynchronous command. A promise says something will eventually happen. So if you think about async and await in .NET and JavaScript, a promise just says we're doing something asynchronously, and it's either going to return at a later time or it's going to fail. So in this convention, this is a promise that it's going to asynchronously load the WebAssembly. Once it's loaded with the result, then it's going to execute some more code. And if it fails, it catches and calls this console error. Does that make sense?
Yeah.
So we'll look at this main.ts. Now this is very interesting. JavaScript itself cannot compile to WebAssembly because WebAssembly is a strongly typed language. WebAssembly has things like integers, things like floating point, things like byte arrays, whereas JavaScript is a dynamic language. TypeScript, on the other hand, is a superset of JavaScript, and TypeScript has types available. So with this feature called AssemblyScript, I can use TypeScript and define code that then compiles into WebAssembly. So here we've got this similar add function. In fact, I'm going to build this, and you can see we've got this main.wasm that was built from the TypeScript. And if I click on that, you can see it looks very similar to the raw WebAssembly. But instead of having to write it at such a low level like this, I was able to write it in TypeScript and compile it out to that. So that makes life a little bit easier for me. And then if I run this, I get the same result, 42. Now, you may wonder what other advantages are there. So we talked a little bit about it's a compile target, so I can target it to write my code. But what else does it provide? Well, here's an example that I have called Compute Prime. So this is a GitHub repo, and I'll zoom in so you can see it, but I've got some JavaScript code, and what this JavaScript code does is it is a very inefficient algorithm to compute prime numbers. And it's inefficient because it's using a brute force attack, and I'm trying to find the highest prime number. If I wanted this to be an efficient algorithm, I would start at the top and drop down. But I'm starting at the bottom and working up because I want it to take some compute time so you can see what's going on. But basically it's using division to determine if it's a prime number, which is a number only evenly divisible by 1 or itself. So I've got that written in JavaScript. I also have a C version of this using the C language. We're going back in time now. And I have very similar code for computing the prime. The difference with this code is that these numbers are defined as integers. And if you're familiar with how computers perform mathematical operations, integer math is always faster than floating point math. In JavaScript, I only get what's called this number type that's represented as a floating point in memory. So I'm using floating point math. Here I'm specifying that it's an integer. So what I've done is I've compiled this into a WASM file, and I'm going to go into my Windows terminal, and I'm going to show you right here this primes.wasm. This is the compiled bytecode, and you can see it's extremely compact. It's only 112 bytes in size. So very small code sample. But if I come back to my web page, let's zoom in just a little bit for you here. I'm going to click this JavaScript, and I'm sorry I don't have a zoom feature for the console, but I'm going to read what it's showing for you. That console is computing a prime, and it's taking a long amount of time because it's this brute force operation. In fact, it took 12 seconds to figure out the prime. Now I'm going to click on this WASM button, which is the exact same thing but done in WebAssembly. And I'll click on the WASM. It's telling me it's computing the prime. It's taking some time. We'll let it run. You know, we might cheat a little bit and move there we go. So we've got 8 seconds. So 8 seconds versus 12 seconds. That's what, a 25% improvement. The reason why that code ran faster, even though it was very similar code, is simply because it was able to do that floating or that integer math, because the WebAssembly format is strongly typed running inside the browser. Now here's the kicker. WebAssembly is in stable release, and it's available in all browsers, all modern browsers, I should say. So the latest versions of the major browsers, Chrome, Edge, Safari, etc., Firefox, support WebAssembly without any additional plugins or add-ons. That means that this code will run just as well on my laptop as it will on my phone, where I had to browse to this and run it. So that takes us to an interesting observation. In 2017, shortly after WebAssembly came out, a team was able to use that mono framework that Scott Hanselman referenced earlier in the talk and build a version of .NET that runs on top of WebAssembly. Now remember, WebAssembly is just a virtual sandbox that you can target, and so they were able to take that runtime and create a version of it that runs on top of WebAssembly. Now, .NET by itself on WebAssembly isn't interesting because remember, well, isn't as interesting as it could be because we still have this sandbox. In other words, .NET running on WebAssembly has no idea it's in a web browser. It has no idea about HTML, CSS, etc. So there's something we have to do, but before we jump into that, let's talk about why we would even care about using .NET in the browser for apps. One of the very popular reasons is because it gives us access to modern languages. We can use things like C#, F#, etc. to build experiences. There's a huge ecosystem of existing code and libraries that are available. The .NET framework is continuously being optimized for performance, and so that performance makes it a very viable runtime to run in the context of WebAssembly. It allows for full stack development using tools that we're familiar with, and it's a very stable and mature platform. Now, I mentioned that by itself, it can't do much because .NET inherently doesn't understand the web. That's why we have ASP.NET on top of .NET to provide that layer. So what Blazor does is Blazor is that intermediary layer that connects .NET to the browser. And the idea of Blazor is that the way you describe your pages is using Razor templates. Razor templates in the browser is where Blazor got its name. So now you know the background behind the name. Razor is just a template format. I'm going to show you examples of that. But the nice thing about using Razor is if you're building existing ASP.NET MVC applications using Razor components, you should be already familiar with the approach that's needed to build Blazor applications. So just to take a step back and look at what this stack is. We've got WebAssembly, which is native to the browser. We've got a version of .NET that runs on top of WebAssembly in the browser. And then we've got Blazor, which gives us all the features we want to build web applications. And that's our full stack. So let's go ahead and jump in and make our first Blazor application. I'm inside of Visual Studio, and I've picked a Blazor app. And to get this Blazor app, I've basically just installed the ASP.NET workload. It's part of ASP.NET Core. And this Blazor app functionality is available for me. So I'm going to click Next. I'm just going to keep, let's actually put this in temp so I'm not wasting too much space. We'll click Create. And it's going to spin up a new project for us. And it's asking me for additional information. And of course, we have this fun dialog that's kind of off to the side. So let's try to bring it back down to size. I'm going to actually, let's pop it to another window. Fun with sizing issues. We're almost there. I think I have the longest or the widest dialog in the world. So I don't need to configure it for HTTPS. I'm going to pick a Blazor WebAssembly app. I know you can't see everything. That's okay. We're going to do this ASP.NET Core hosted and create. So one of the things I just did is I checked a box called ASP.NET Core hosted. The reason I did that is Blazor in and of itself is basically, sorry, I lost my train of thought. I was distracted here. Blazor by itself is a single page application. So if you've worked with React, if you've worked with Angular, if you were in the Knockout.js or the Backbone, you can build entire web app experiences that the application part that's served to the browser is just a set of HTML pages and maybe some JavaScript. The way those apps come alive, the way they're dynamic, is they talk to web API endpoints, they interact with data on the server. But Blazor by itself as a WebAssembly flavor, and we'll talk about flavors in a second, is really just a set of static assets that can be loaded in your browser. When you choose to have an ASP.NET Core hosted project, what you're saying is I not only want those static files to be available, but I also want to go ahead and have a controller on my server so I can stand up those web API endpoints. So let's actually run this, and then I'm going to dissect what the code behind looks like. So I'm just going to do debug. Let's do start without debugging, Control F5. And this is going to build the application. What's important to note is what we're really building here is a set of .NET standard DLLs. This is .NET Core. We are building mainly the same DLLs that can run locally on a desktop or even in like the case of Xamarin in a phone. We're running that similar system of .NET standard DLLs, but we're placing it on top of the Blazor framework so it can run in the browser. So here we can see it's registered a URL, it's running, it's got an endpoint. So I presume if I come back over to my web page, I now have a Blazor application running. Let me just zoom in. Actually, we just established Zoom isn't working that well, that's fine. So I've got this home page. You can see there's a brief survey. I've got a counter. If I click on the counter, we can see the counters incrementing. Here I'll zoom a little bit, make this easier to see. So the counter's going 910. I have fetch data and it loads data from the server. What's interesting is if I go back to the counter, it reset to 0. I'm going to talk more about that in a minute. If I go back to fetch data, each time it's going to fetch a different amount of data. Let's do something else. Let's open up our debug tools. Open up the network tab and let's refresh this page and look at what is actually coming in. So what we've got, if we look at the order, we've got some an endpoint called fetch data. That looks pretty normal. Then we've got this style sheet, no problem. We can do style sheets all day long. We've got some JavaScript, that's great. But then we've got this mono.wasm. So what we've done is we've loaded JavaScript. That JavaScript has loaded a WebAssembly bytecode file. This is the .NET runtime designed for the browser. And here's what is actually amazing, is after that runtime is loaded and ready, everything after that is DLLs. And again, these are the exact same DLLs that you can run locally being loaded into the browser and executed inside of the browser. And I'm going to point out we've got this Blazor app client, we've got this Blazor app shared, and then we've got a bunch of different DLLs. Okay, so let's take a look at our project and break that apart a little bit. Inside of this project, I've got a shared project that has a weather forecast class. And this just has some properties and some code. So this isn't just a data object. This one actually has some logic here. If I go to temperature Fahrenheit, it's doing a conversion from temperature Celsius. On the server, I have a controller for the weather forecast. And what we can see is it's using that shared DLL, and it's using it to generate some random weather forecast information. That's what this get method does. It's just randomizing that information and returning it back. So this is an endpoint I can hit, and what it'll return is JSON weather data. Where it gets really interesting is when we go into the Blazor client. The Blazor client itself has a reference to the shared project. If I zoom in here, we can see that there's this Blazor app 8 shared. So it's referencing the exact same project that I used on the server to create the data. If I go inside my pages and I look at this fetch data Razor template, we're going to see a couple things. Here in the upper left, we're going to see what's called a route. So this page directive says I can navigate to this component using fetch data in my browser. It's bringing in that shared library, and it's also bringing in the HTTP client. The rest of this template is HTML, so there's an H1 tag, a P tag, and then here's some Razor logic. The cool part about this is this code to fetch the forecast is just using the same HTTP client that you use in regular .NET applications. This is running inside the browser. We are now looking at browser client code, but we're using C# and we're using familiar classes like the HTTP client to make that fetch. So that's pretty powerful. You also notice that in the main page, in the index page, we had that survey prompt that was asking, if you want to give feedback, whatever. This is a reusable component. So you can see I have this tag survey prompt. Under my shared folder, I have my reusable components. The survey prompt is just some HTML. The code just basically gets a title. And if we come back to the index, we can see we set the title right here. How is Blazor working for you? This is all it takes to create a reusable component. I can put multiple versions of this. I'll do survey prompt, title. This is the techWebinarNepal. And then we can launch this application, do a rebuild. I just want to show how easy it is to reuse a component in Blazor. So let's launch this up. Give it a second, and of course you know this trick, right? Move the mouse clockwise, speeds up the build process. And there we go. And here we've got the first prompt, how's Blazor working for you? And the second prompt, this is techWebinarNepal. Now, if I open up my inspector, and this is really important, and I look at what does this survey prompt look like? It expands as regular HTML inside of the browser. So this is no special UI rendering framework. It's all HTML, but it's Blazor that's managing all of that logic. So let's step out. So that was a very simple file new Blazor example. But what I want to show you is that Blazor provides a variety of services that make web applications possible. It handles dependency injection. We're going to take a look at that. It has a component model to make it very easy to create reusable components. It has debugging built in. There's routing so that I can have different URLs to navigate to portions of the site. There's assembly trimming, which means it's going to take those DLLs that are served to the browser and remove code that's not accessed. There's forms, publishing layouts. There's a lot to Blazor. One of the things that I mentioned earlier is that there's a couple different flavors of Blazor. And this is sometimes confusing, so I want to sort of clear the air for this. Blazor itself initially was built as a project for running .NET in the browser. However, it became very evident that there is a lot of functionality needed to make this an effective means of running in the browser. We need performance optimizations, we need to trim the assembly sizes, we need to do several other things. So there's some work left to do it. However, the way Blazor was architected, the logic for how you set up templates and organize code in Blazor is separate from the logic to actually render the Blazor components. Those are separated inside the architecture. So what that means is they were able to create two versions of Blazor. The version that I'm focused on is client-side Blazor. This is WebAssembly in the browser. Blazor's running entirely inside of your web browser. This version of Blazor is in preview. It's not scheduled to release until May of 2020, so we have a few months ahead of us. However, there is a server-side version of Blazor that uses the same logic, the same code, but instead of running WebAssembly in the browser, it provides a very thin JavaScript client that uses real-time communication. It's actually SignalR to talk to the server. And the server will keep track of sessions and do rendering, etc. The reason why this is important is this server-side version of Blazor, which is basically shifting the burden to the server to do the rendering and the logic, is in production right now. You can release production-ready code. So as a strategy, some companies are looking at just using server-side Blazor because it still allows them to use C# and .NET to build full-stack experiences. Some companies are very interested in the client-side Blazor. So what they're doing is they're building components that run server-side for now, but will shift to client-side. That's the beauty of it, is the same code can run in server-side and client-side Blazor, and there's ways you can detect where you're running. Now there's trade-offs if you decide to go with server-side Blazor. It's a thinner client because it doesn't have to load the entire .NET runtime into the browser. It allows for the full runtime on the server, and it's a simpler architecture. I would also add another pro is because your logic's running on the server, if you have intellectual property, if you have code that you don't want distributed or inspected, then you can protect that code by keeping it on the server. The cons is that there's no offline mode. With a Blazor WebAssembly app, you can actually install it as a progressive web app, run it offline. It doesn't have to have an active connection to stay alive. Server-side Blazor requires that connection with the server because the server is handling the rendering, the state, etc. This introduces a little bit of latency, and it also increases the resources on your server. If you can imagine, if I have 10,000 clients connected in Blazor, with WebAssembly Blazor, the majority of logic is distributed across 10,000 nodes. It's running inside of everyone's browser. With server-side Blazor, there are 10,000 sessions being maintained on the server. So it adds extra load to the server, but that trade-off is actually not as huge as it may sound. The team has done stress testing and performance testing and found that it holds up to massive scale. And then in addition to that, because of the fact Blazor's architected this way, You can also do things like create a Electron style desktop application in Blazor. So there are a lot of possibilities, and I think in future versions of Blazor, you're going to see built-in support for experiences that go well beyond just the browser. So let's do a little bit more with Blazor. I want to dive in and show you some power of what Blazor is capable of doing. So I'm going to take off this survey prompt. Now, earlier when I ran the web application, I pointed out that the counter, when I click this and go home and come back to the counter, it resets to 0. So we're losing some state. This is because the way the counter is implemented right now is as part of the component. So here's a component. I've got some HTML up here at the top. This is how in a Razor template I indicate data binding. So this is saying after this @ symbol, evaluate this property and show the value of the property. The property is defined right here as current count. And then this is how I indicate an event. So in the JavaScript on click event, I wanted to call the C# increment count code right here, current count ++. This is inside a component. So every time I navigate to that component, a new copy is created and that count gets initialized to 0. So let's fix that. What I'm going to do is come here and I'm going to create a new class. So I'm adding new item. It's going to be a class and I'm going to call it counter service. So here's our counter service class. And I'm going to have a count, but I'm going to give it a private setter. And then I'm going to expose a method called increment that increases the count by 1. So this is just a very simple service at this time. Now, if you've done any ASP.NET MVC development, you know that there's this startup that allows you to handle configuration and services. That same model exists in Blazor applications. So even though I'm running in the client, I can still take advantage of things like dependency injection. So what I'm going to do is say services, add singleton. I'm going to say when I want a copy of the counter service, give me an implementation of the counter service. So this is basically saying I always want one copy of the counter service to be available for this application. So then what we can do is we can go into the counter and we can tell it, please inject the counter service, and let's call it counter SVC. So what I'm asking for is I want a copy of this, and I'm going to make it a property called this. Now when we do current count, what we can do is instead of getting it from the component, we can get it from the counter service. And then in our increment count, we can just say counter service dot increment. So let's see if I've done this all correct. We're going to go ahead and build that and launch it. So what I just did is I used the services made available to me to register a service with dependency injection. And I said it's a singleton, so I just want one copy of that throughout the application. So when we do that, what we should see is as it loads, and we've got our counter. We're going to click. You can see it's incrementing. Let's go home, come back. Now it's preserved that state. So we've fixed the state of the counter by registering a service. In a lot of applications, you may use something like the model view model pattern, the MVVM pattern. If you're a WPF developer, you work with Silverlight, you're probably familiar with that pattern. And you can register those view models and use those in views throughout. Now there is another step though that I need to take here because it's not working perfectly yet. And I'll show you why. I'm going to go to, so our count is at 11, I'm going to go to the home page and I'm going to manually navigate to the counter. You can see it's reloaded the entire Blazor application, and because of that, it's lost that service state in memory. So I've lost the current count. Now, in a typical type of web client, you would probably be connecting with an API endpoint and talking to a server that's keeping track of that for you, so it's fine. But if you wanted some small state to persist on the browser, there's a few different approaches we can make. One that I like to use is the local storage that's part of the browser. So all modern browsers have a local storage mechanism. However, there's no native way to get in touch with local storage from Blazor. So what we have to do is write some JavaScript and interoperate between C# and JavaScript, and Blazor makes that very straightforward. So what I'm going to do is, in the part of my site that has static assets, I'm going to add a new item, and this is going to be a JavaScript file. And I'm going to call this counter service. Actually, let's call it storage service. Give it a name that makes sense, .js. So what I'm going to do is put this on the window object. This makes it globally available to everything in the application. And I'm going to do some very simple JavaScript here. So counter service is my namespace, if you will. That's my API. So I'm just setting that up. I'm going to have two methods. I'm going to have a load method that is a function, and I'm going to have it return local storage count. This is an API that's made available from the browser, and this is a key to a value that I'm referencing. So I'm saying, give me that local storage count value. I'm also going to create a save function that takes a value, and I'm going to take local storage count. I'm going to set it equal to that value. So I have a way to load it and a way to retrieve it. So now I've got that storage service. I'm going to go into my template, and right after I load the Blazor WebAssembly, I'm going to go ahead and load my storage service. So now it's available. So for this last piece of functionality, what I'm going to do is extend my counter service and provide it an initialize method. Initialize just sets the count to an initial value. So that just gives me another way into it. Then I'm going to go into my counter. Now I need to interact with JavaScript to access that code I just wrote. So what I'm going to do is inject the JavaScript runtime. This is a service provided by Blazor to interoperate with JavaScript. I'm going to do a couple things here. I'm going to override on initialized async. So this is a method that's called when the component is first initialized. What I'm going to do is try to retrieve that value from the code I just created. So I'm going to grab it as a string because that's the way local storage works. And I'm going to tell it, we called this, what did I call it? Let me just make sure I give it the right name. I called it counter service, even though I named the file storage service. That's fine. So the namespace is counter service, and the method is load. So this is the way I say I'm going to cross over into JavaScript land from C# and grab a value. Then what I'm going to do is try to parse that value out. If I'm successful, I'm going to initialize the counter service with the value that I retrieved. The other thing I'm going to do is every time I increment the count, I'm going to go ahead and save it. So that's another await. Let's actually change this to an async method. We're going to call the JS runtime again, invoke async. This time I don't care about the return value, so I'm just making an object, counter service.save, and I'm going to give it the counter service.count as the value. So again, what we're saying is when this component first loads, let's see if we have something in storage by calling out to JavaScript. Anytime we change it, let's go ahead and save it out. Now what I'm going to do is go ahead and run this.
So in the meantime, so there is a QA question.
Yes.
Yeah, so how can I build multiple projects as multiple WebAssembly WASM file and share them? WASM file and share them.
So the answer is complex. The question is how can I have multiple WASM? So what I showed you earlier, there's a WebAssembly object in the browser that actually allows you to instantiate code. And you do that by doing an instantiate then, and you have access to the exports. So if I can have one or I can have 50 WebAssembly projects and keep references to them and run them. Blazor itself is designed more to be a single application framework. So what you produce is going to be everything you need for the application. You could call other WebAssembly if you wanted, the same way that I just showed this JavaScript Interop. It's just a question of if you need to or what the motivation behind doing that is. But WebAssembly itself, you can instantiate, just like you can include multiple JavaScript files, you can instantiate multiple WebAssembly instances and do that. Blazor sort of makes that transparent so you don't have to worry about directly managing it, if that helps. Let's go into our counter tab. We've got a current count of 0. And what I'm going to do is open up my tab, go into Application, Local Storage for this app, and you can see there's this key value. There's a key, there's a value. Right now it's empty. Let's go ahead and click the counter. Now it's going to 1. And if we notice in our storage, it's created this key of count and it's initialized this value of 1. So now I'm going to go 2, 3, 4, 5, 6, 7. Let's go home and let's re-navigate to the counter. Remember earlier, because nothing was stored in memory, this actually destroyed the value of the counter. This time when I go to counter, it's loading. Now it's initialized to 7. So it's maintained that state. And what I've showed you is one way to address Blazor state. There's other ways to do that, and we'll go into those. But the other thing that I've shown you is how to interoperate with JavaScript. And this actually works both ways. So the same way I can call out to JavaScript from WebAssembly, I can also call C# methods from JavaScript. But I want to show you one more thing. I know we're getting short on time. So before I completely close out, I want to just provide one more benefit of Blazor. Let's go ahead and go into this index page and let's see if I can do this in a record amount of time. I'm going to create a code block, public string text in, public string text out, and public void transform This is text out equals text in. We're going to create a text area. Let's give it 5 rows. Let's give it 100 columns. And we're going to bind it to text in. We're going to do a button that the button on click goes to transform. And I have another text area. We'll do same rows, same columns. We're going to make this one disabled, and bind is text out. So what I've created is a very boring implementation of moving text from one field to the other. Let's run that really quickly. And we'll spin it through, and I'm going to keep an eye down here, see if I have extra Q&A come in really quickly. Multiple projects, new.
Yeah, so there are few questions. So can I shift / modify my extensing web application .NET Core or older to Blazor without starting from scratch?
Yeah, it depends on how you've architected your application. I know that those aren't the most fun answers, it depends, but it is still C#. So the extent that you have, for example, if you're using Razor templates, you can share those Razor templates to Blazor project, and C# code you can share. I've actually taken WPF projects that have view models, so that's C# code and logic, and ported those to run on Blazor. And I've had to wire up new UI, but I was able to reuse that C# code. Hopefully that answers. So what we're doing here is we're saying hello, and then we click transform, and the hello moves down here. Pretty boring. What would be cool is, let's say I was building my own blog engine. I wanted this to be Markdown. So Markdown is a special format for marking up documents. This is header, subheader. This is how I do a list. I do like 1, 2. And right now, transform is going to be a little boring because it's just going to copy that Markdown code. Let's change that. So I'm going to go into my client and manage NuGet packages. And the reason why I'm showing you this is to demonstrate what I think is just the incredible power of Blazor. I'm going to search for Markdown. And here we can see we have Markdown, Markdown Sharp. This is a library that if we look over here in the details, it targets .NET Standard. Right here, .NET Standard version 2. Even though this was never intended to run in the browser, I'm pretty confident the author of this was building it as a console app or a server-side app or whatever. But what this does is it transforms Markdown format that I showed you earlier into HTML. So what I'm going to do is go ahead and reference this. And this is a NuGet package, so I'm not pulling in source, I'm not rebuilding anything. I'm just pulling in this package, and I'm going to go back into my index, and I'm going to add a using statement. And let's actually build this really quickly to get IntelliSense on my side. And build. Preview version, we know that, that's great. Client, and should be almost there. Okay, using Markdown chart. So I've got a using statement to use that library that I just referenced. I'm going to save our Markdown equals new Markdown. So this is the class that's exposed by that API. And I'm going to change text out to be markdown.transform text in. So I'm again using an existing DLL that was built for the server. This time I'm saying I want to pull it into my client browser project and take advantage of it. So let's see what that looks like. I'm going to open this up in my browser. We've got 1 minute to spare, so I'm going to ask the compile process to do it expediently. Maybe add some clockwise juice here. And we're almost there, and there we go. It's building the server-side project. That's to host it. It's launching it. And loading, loading, loading. Okay, so let's do one. This is a subheader. I'm going to do a list. 1, 2. Let's give it some space. And then using Markdown format, this is my blog. https blog.jeremylikness.com. And we'll click transform. And immediately what we get is the HTML parsed from the Markdown using an existing library. And that is why Blazor is such a powerful tool, because it allows you to take advantage of existing .NET libraries. Let me give you one more slide so that you can screenshot it, and then I will make sure that I give up the floor to our lightning talk speakers. This is a link to a project, this github.link, that will walk you through building Blazor apps from start to finish, including exploring features of it. Think of it as a open source hands-on lab. This is my blog, and I have several posts related to Blazor for more advanced topics, things like sharing logic between the client and the server. So be sure to check that out. Thank you for the invitation. So happy to share Blazor with Nepal, and I'm going to pass it over to our hosts.
Yeah, Jeremy. So there are two questions. Razor or Blazor, where should I start?
I would start with Blazor because you're going to learn Razor as a part of that. But Razor is simply the way that you can share components and the way that you mark up the UI. So as part of learning Blazor, Razor is really the rendering engine for it. So if you're building web apps and you learn JavaScript, you need to understand HTML and CSS. In a similar way, when you build Blazor, understanding Razor helps you understand the UI aspect and how to share code and resources.
Okay, sure. Can you give us few example of web app that is built in Blazor?
There is actually Blazor. I hate to do this vanity Twitter scan of my own profile, but I actually recently linked a resource that I think will be incredibly helpful. Let me find that. There is a place that has a ton of Blazor references. Okay, right here. So if you look at this short link should be straightforward. It's JLIK, which is my name, .me/G3X. That's what I'm going to click on. I have a tweet for that. But this is going to take you to a GitHub repo. And this repo is just tons and tons of Blazor resources. We have this upcoming Focus on Blazor Day that's going to be January 14th. It's a full day webinar focused on Blazor. But this links you out to sample projects, tutorials, libraries, videos, articles, podcasts, the whole 9 yards. So if you go to this one site, this awesome Blazor, and you could probably just do a Google or a Bing search, Google Bing it, and find it. But this will give you connections to tons of different resources and sample projects and examples, etc.